Any questions on any of the homework? So what we're looking at today is flow charting and working through these proofs using kind of a flow chart. It's more systematic and more laid out way than what we've been doing so far. And we want to solve these or prove these statements. So here we want to prove that angle A is congruent to angle E. And we're going to most likely prove it by our CP, CGC. Our corresponding parts of congruent triangles are congruent. Now, to start any of the proofs, we always start with what? The given. So they tell us that EC and AC are congruent. So we can put that first. EC is congruent to AC by, well, it was given to us. What else do we? ER and AR are congruent. AR. Okay. Given. So far we do have two sets of sides. Do we have anything else that is congruent? RC is congruent to RC. Really, we would say that this is the reflexive property of equality, or we can just say same line, congruent to itself. So really, what can we say from this here? That okay. Almost. ACR by our side congruency statement. So where can we go from here? By And this is how we really had to go about proving that these two angles were congruent. Because we really had nothing to tell us that the two angles themselves or anything about the angles. But if we could prove that the two triangles are congruent, and we did, then we can say that their corresponding parts are congruent as well. Is angle A and E are corresponding. I mean, these two angles are corresponding, and these angles here would be corresponding as well. Any questions on this here? Copy the chart proof and provide the missing information, or we're just going to go on and prove it. Now, yes, so we can start off the given. I see. And yes, you are congruent. What else do we know? Angle E is congruent to angle Q. This was given, and this is given. Now, what are we wanting to prove? MS and OS are congruent. Now, with this one here as well as the last one, are we given any information about the pieces that we want? So we weren't given any information about the angles on the last one. Do we know anything about the side lengths? No. But if we could say that these two triangles are congruent, then we can say the corresponding parts are as well, yes? And that's really what we're doing. Now, is there any other information that we can say in these two triangles that are congruent? Any other sides or angles? Angle 1 would be congruent to angle 2. Now, why can we say that? By vertical angles. So we have a side length of 2 angles. Now, this is not going to be by side angle. What would it be by? Angle, side, angle, because we have an angle, a side, and an angle. We have an angle, a side, and an angle. Because even though we set up the proof in the flowchart as side, angle, we do have 2 sets of congruent angles with a side in the middle. So this here is going to be by angle, side, angle, which is one of the ones that works. That means that I get triangle what? ESM is congruent to triangle USO. Does it really matter how I set up the first triangle? No, we just need a way to name one of them and then have the other one follow in the same pattern. Then what were we wanting to prove? Is congruent to OS by CPCTC. Questions on this here? Now we have a little bit more information than we did before, yes? There's a lot more boxes. What did it start off with telling us? The given, we have I is the CM and I is the midpoint of BL. And we want to prove that CL is congruent to MB. Use a highlighter. So these are the side lengths we want to prove that are congruent. Now, even though I is the midpoint of these 2 lines, that really doesn't tell me anything about the line lengths themselves, correct? Because it could be that they are congruent or it could be that they're not. We can't tell at this point. But we can still prove it because it will work out. And we have to start off this midpoint of CM. I is the midpoint of BL. And this is our, luckily, y'all will be able to fill that in a little bit better than I can. Fill it in as best you can, because that's what we have first. What do we know about a midpoint? What does a midpoint do? In half into 2 what? 2 starts with a C. Congruent segments, yes? So if I is the midpoint of CM, it means that what? C is, we can say that CI is congruent to IM. Well, how do we know that? It's by the midpoint. Because we said I was the midpoint. Because I is the midpoint, it cuts it into 2 congruent segments. That's just definition of midpoint. Well, that also means for BL, well, we also have that what? B I is congruent to IL by definition of So we have two sides, yes? Two sets of congruent sides. So out of all the ones that work, our congruency shortcuts are side, 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 angle, side, angle, side, angle, 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 side, or side, angle, angle. And the one we looked at yesterday, hypotenuse leg, really only works if it is a right triangle. All right. So we have these here. These are the ones that work. The ones that didn't work were angle, 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 or side, side, angle. So if we were given two sets of sides, we're either looking for a third set of sides. Well, we know it can't be that, because that's what we're trying to prove, that the third set of sides are congruent. So we're going to most likely need a what? Are there any angles that are congruent in this? Angle 1 and 2. 1 is congruent to angle 2 by vertical angles. So we do know that these two triangles would be congruent by side, angle, side, because that's how we have them set up. So we can say triangle what? CIL, almost, because C, we start with C, go along the side with 2, and then along the side with 1. Because since we start at C here, 2, and then 1, so the way to go down the long, to go to 2 to 1, we need to start at and go from 2 to 1. CL is congruent to MB. By CP, CT, C. That'd be it. Questions on this here? We ready for the next one? Take the flowchart proof of the isosceles triangle conjecture given that the triangle is isosceles. Show that the base angles are congruent. So we want to show that angle W is congruent to angle E. Now we're given the triangle NEW is isosceles with WN congruent to EN and median NS. Okay, so what do we know so far? Line WN is congruent to line EN. And really that's because this triangle is isosceles. And really from it being isosceles, we can say that WN is congruent to EN. Now the other piece of information we're given NS is given.
PJ Jack, come to the office. PJ, come to the office.
Now, by definition of a median in a triangle, it's going to connect to the midpoint of the opposing side. I know I drew a right angle, but that's not the median. Because the median is going to connect to the opposite side and opposite side's midpoint. Always get these a little backwards. Yes. Yep. The median of a triangle is a segment from the vertex of a triangle to the midpoint of the opposite side. So really that's telling us that WS is congruent to SE. Given definition of a median. Really, the top one here, we could say given or definition of isosceles triangle. The reason we can go either way is because, well, it told us. Because isosceles is really just telling us that two sides are going to be, we needed actually a little more information to know which sides they were talking about. So we're given two side lengths in each triangle, yes? So what do we need? An angle or a third side. Is congruent to what? Is the thing. Or we could say the reflexive property. So now we can say that the two triangles are congruent. So we can say triangle NSW would be congruent to triangle NSE by side, side, side. So that means that we could say that angle W is congruent to angle E by CT C. Well, it's really worked out on most all of these. Our last reasoning is our CP-CTC, isn't it? So let's look at the next one. Use the flowchart proof of the converse of the isosceles triangle conjecture. Show that triangle NEW is an isosceles triangle. So NEW with triangle, so we're given the triangle NEW with angle W congruent to angle E. And NS is an angle bisector. Yes. Not really started it out by itself. And I wouldn't put angle W as congruent to angle E, because since NS is an angle bisector, do we get information from it? Well, yeah, an angle bisector bisects an angle into two congruent angles. It cuts it in half. So knowing that NS is an angle bisector, well, it's going to cut the angle at N into two congruent parts. It's really just telling me that angle 1 is congruent to 2. Definition of angle bisector. Yes. What else do we know? Angle W is congruent to angle E. That is given to us. It was just told to us that that's true, yes? Yes. I will take same line, but if we were being truly rigorous, we would have to say the reflexive property of equality. Does our reflexive property, yep, says that it pretty much A is equal to A is NS is congruent, NS is congruent to itself. Symmetric is where we can flip it. So that means what? A triangle NWS is congruent to triangle NES by? Because we had angle, an angle, and an angle, an angle, and angle, angle, side. Or you could say side, angle, angle. And really, when you're looking at trying to name these, if you have difficulty seeing it, write it out. Write which sides are congruent, which angles are congruent. And then start with one of them. So I can just start with angle W, yes? If I go this direction, well, I don't have a side, do I? So we don't want to go that way. We can go up. Because even though I don't have a side, I do have an angle and a side. Angle, angle, side. Whenever we're tracing it around, I can't skip a side and an angle. I can't skip both. I can skip one or the other, but not both. And the reason I can tell you this, let me get out later. Because if I start at angle W and go this way, well, I don't have a side. Do I have an angle? Go in this direction. Well, no, the angles at S, do we know what they are? Are they congruent to anything? So going this direction, well, I skip this side and an angle. I can't skip both. Now, if we go the other direction from this angle, well, I do have the angle. Don't have a side, but do have an angle. And then a side. Because whenever we're tracing it out, I need an angle or a side on each one. Because if I go across the side I don't have, and then following up with an angle I don't have, that's not the right direction, go the other way. Does that make sense? So we have angle, angle, side, angle, angle, side. They do match up. So we can say that the two triangles are congruent, which means, well, to be able to say isosceles, we need what? So really, we can say that W2 NE. I don't know. So we can really say that these two are congruent by CP, CT, C, yes? And I can extend this page. So we can really say that these two sides are congruent, yes? NE. Because we have those two sides of the triangle congruent. Well, because of this, we can say that triangle WNE is isosceles by, well, definition of isosceles triangles. Because really having that the two triangles are congruent really doesn't tell me that they're isosceles. We had to have that two of the sides were congruent, then we could be able to say it. Any questions on this here? So you have this one. We'll say this tomorrow, and we'll finish up the lesson tomorrow as well.